For more videos, visit forthesakeofeducation.com. Alright guys, now we're going to do these two problems that says the lug nut on the wheel of the automobile is to be removed using the wrench and applying a vertical force right here of 30 newtons. Find if this force is adequate, knowing that 14 newton meters of torque is required for the lug nut to turn, and that's about the x-axis. So basically what we're going to do is we're going to do a scalar analysis. You know that it can be applied in any direction because that's what it says. So you know that the maximum torque is achieved when the lever arm and the force have an angle of 90 degrees. Now at this point this length is 0.5, so the maximum moment that this force can create is equal to 0.5 meters times 30 newtons, and that comes out to be 15 newton meters. This is bigger than the 14 newton meters required to undo the lug nut, so this is adequate. However, if the force is applied vertically, then you gotta calculate it with this lever arm, which is 0.4. If this is 0.5, this is 0.3, this is 0.4, because we got this triangle. This is 0.5, this is 0.3. Let's call this x. You know that x squared plus 0.3 squared is equal to 0.5 squared. If you solve for x, you're gonna get that x is equal to 0.4. So this length lever arm is 0.4. So the m when f is vertical is equal to 0.4 meters times 30 newtons, which comes out to be 12 newton meters, and it's smaller than 14 newton meters. So if you're applying the force vertically, you're not going to crack that lug nut. Now in the second problem they tell you that we have a cheater pipe. If the cheater pipe is slipped onto the scale, and you can apply the force at any point, then the maximum moment, you're gonna get it when you apply the force at the very tip and at a 90-degree angle, and that force comes out to be 0.25 meters plus 0.5 meters times 30 newtons, and that comes out to be 22.5 newton meters. 22.5 newton meters is obviously bigger than 14 newton meters, so it will be able to crack the lug nut. And last but not least, if you apply this force vertically, you're creating a moment with this lever arm, and this lever arm comes out to be this 0.4 plus this, which comes out to be 0.1. This is 0.25. You know from here you can find the angle theta. When you find this angle, you can do that 0.25 times the cosine of this angle, and you're gonna get that this is 0.1. If this is 0.1 and this is 0.4, the whole thing will be 0.5. So the moment that this creates is times 0.5 times 30 newtons, which comes out to be 15 newton meters, which again is bigger than 14 newton meters, which would also be able to crack the lug nut. So the only time where you're not going to be able to crack the lug nut is when you apply the force vertically at A. That won't do it. If you apply it at 90 degrees, you will do it. If you apply it 90 degrees here, you will do it. And if you apply it vertically here, you will do it as well. Final answer. Please comment below if you want me to do any problems, and I'll be happy to help. Thank you.